Today we are going to take a look at the double angle identities. The double angle identities are used both in pre-cal and in calculus. In pre-cal, we use this identity just to find the trig function of different angles given information involving triangles usually. Okay. We also use them to prove other identities and to manipulate trig expressions. In calculus, we use these to make differentiation and integration easier, to simplify answers, to obtain multiple choice answers, etc. Because of their importance, these two I want you to memorize. Okay? They will not be given to you on the test. You'll have a formula sheet with the other trig identities, the sum and difference ones, and what we're doing next, the half angle ones, but not for the double angle ones. I don't think that they're hard to memorize. Sine of 2x is 2 sine x cosine x. Not bad. 2 sine x cosine x. I could easily show you that using the sum and difference. Sine of x plus y we know is sine x cosine y plus cosine x sine y. That's what we did yesterday or in our previous lesson. If these two are the same, then that would be sine x cosine x plus cosine x sine x. Well, that's the same exact term, so that is 2 sine x cosine x. That's the identity. Okay? I could also show you where this comes from, but the identity for cosine of 2x is, let me show you where this comes from. Cosine of x plus y, we know that is cosine x cosine y minus sine x sine y. So what if those are the same things? Cosine x plus x. That would be cosine x cosine x minus sine x, which is cosine squared x minus sine squared x. And that is the identity for cosine of 2x. Okay? So these we'll memorize. Let's look at some examples. We're given that sine x is negative 12 over 13, and we are in quadrant 4. So let's draw that out. If this is angle x, so sine is negative 12 over 13. That'll make this a negative 12. The hypotenuse is 13. I know the adjacent side has to be a positive 5. Positive because we're on the positive x-axis. And therefore, I know that sine of x, that was given to us to be negative 12 over 13. Cosine of x, oops, not 12, 13. Cosine of x is positive 5 over 13. Okay? And for these, we're not going to need to write what tangent x is. Okay? So sine of 2x is 2 sine x cosine x, which is 2. Sine x is negative 12 over 13. Cosine x is 5 over 13. Okay, it's going to be a negative. 2 times 60. 12 times 5 is 60, times 2 is 120. 13 times 13 is 169. And that's that. Cosine of 2x is cosine squared x minus sine squared x. Okay? Like that. Cosine of x is 5 over 13. Sine of x is negative 12 over 13. 5 squared is 25. 13 squared is 169. Minus, when you square this negative, it's going to be a positive. 12 squared is 144. 13 squared is 169. We'll subtract those, and we're going to get a negative. Okay, let's see. Well, 14 minus 5 is 9. We borrowed 1, so that's a 1. So negative 119 over 169. Okay. For tangent of 2x, I don't memorize another formula. Okay? I don't. All I do is take sine of 2x and divide by cosine of 2x, because tangent is sine over cosine. So as long as we keep the correct argument, we're in good shape. I don't memorize another formula here mainly because the two formulas for the sine and cosine of the double angle, they're both so easy and quick, so I don't want to memorize another double angle formula. So sine of 2x we found was negative 120 over 169. Cosine of 2x was a negative 119 over 169. If I multiply top and bottom by 169, those 169s vanish, and I'm left with, two negatives make a positive, I'm left with 120 over 119. Okay, that's that. Let's look at another example. Now we're given that cotangent of x is negative 3/4 and x is in quadrant 2. Okay, and ignore this. I had copied it and pasted it from a multiple choice question, so ignore that. Let's write our quadrant 2 angle, x. Cotangent is negative 3 over 4. That means adjacent over opposite will be a 3 and a 4. Which one gets the negative? The one on the negative x-axis gets the negative. And the hypotenuse here must be a 5. Okay? So I'm going to write what sine x and cosine x are. Sine x is 4/5. Cosine x is negative 3/5. All right, sine of 2x is 2, sine x, cosine x. Since you need to memorize these formulas, make sure you write the formula every time. If you write the formula every time, you won't have to work to memorize it. You will just do it naturally. Okay, sine x is 4 over 5. Cosine x is negative 3 over 5. This is going to be a negative. 2 times 12 is 24. 5 times 5 is 25. Negative 24 over 25. Cosine of 2x, the formula is cosine squared x minus sine squared x. Okay? So something squared minus something squared. Well, cosine of x is negative 3/5. Sine of x is 4/5. When we square this negative, it'll be a positive, so we're going to have 9 over 25 minus 16 over 25. 9 minus 16 is a negative 7. So negative 7 over 25. Tangent of 2x is going to be sine of 2x divided by cosine of 2x. Well, sine of 2x is negative 24 over 25. Cosine of 2x is negative 7 over 25. If you multiply top and bottom by 25, we're going to get 24 over 7. And it's going to be positive because they're both negative there. Number 3. Cosine squared of 10x minus sine squared of 10x is equivalent to which of the following? Well, when I see cosine squared minus sine squared, I think of the double angle formula. The double angle formula says cosine of 2x is cosine squared x minus sine squared x, right? Well, what if this is a 10x instead of a plane x, and this is a 10x instead of a plane x? If this is a 10x, then this will have to be 20x. So this is cosine of 20x. Using the double angle formulas in a little bit of a different way. Okay. Let's find the value or values of x in the interval from 0 to 2 pi that satisfy this equation. So we have sine of 2x minus cosine x is 0. Okay? Well, what can we change sine of 2x to? We can change sine of 2x to 2 sine x cosine x. Now we are going to factor. I see a common cosine x. There's a common cosine x, so I'm going to take it out. When you take it out, you're dividing it out. So I have 2 sine x cosine x, and I'm dividing by cosine x. I'm left with 2 sine x minus, now I have this cosine x, and I'm dividing by cosine x. I'm left with 1, because cosine x divided by cosine x is 1. Now I have two things being multiplied together to get 0. So that tells me that one of those two things, at least one of those two things, must be 0. So either cosine x is 0 or 2 sine x minus 1 is 0, right? Well, cosine x is 0. I like to go and look at the graph of cosine. The graph of cosine, just from 0 to 2 pi, because that's what they're telling us to do, just from 0 to 2 pi, the graph of cosine, one period of cosine, starting at 0, ending at 2 pi, looks like that. Cosine is 0 here and here. Well, what are those angles? Halfway in would be pi, so this is pi over 2 and 3 pi over 2. So this gives me x is pi over 2 and 3 pi over 2. Over on this one, I'm going to do a little algebra. I'm going to add 1 to the other side, and then divide both sides by 2. And I get sine x is positive 1/2. In my mind, I'm thinking of quadrants. Sine is positive in quadrants 1 and 2. The reference angle is pi over 6. So this will be the pi over 6 angle in quadrant 1 and the pi over 6 angle in quadrant 2. Back to solving equations. This time we may have a double angle to use, a double angle identity to use. Number 5. Find the x-intercepts. The x-intercepts of the graph of this from 0 to 2 pi. Well, the x-intercepts occur when y is 0. So essentially I'm going to take this and set it equal to 0. So sine of 2x minus square root 3 sine x is 0. I'm going to use my double angle identity for sine of 2x. That is 2 sine x cosine x. I'm going to write everything else down. And now I'm going to factor. Now I see I have a common sine x, so I'm going to factor it out. Again, when you factor out something, you're dividing it out. So when I have this and I divide out a sine x, I'm going to be left with 2 cosine x minus, now I have square root of 3 sine x, I'm dividing by sine x, and I'm left with just that square root of 3. So I have either sine x is 0 or 2 cosine x minus square root 3 is 0. Well, sine x is 0. I think of my graph of sine. Sine from 0 to 2 pi does this. And sine is 0 at 0, pi, and 2 pi. All 3 answers. I use all 3 because they told me to go from 0 to 2 pi, including 0 and 2 pi. Okay? Over here I'm going to do a little algebra. I'm going to add the square root of 3 to the other side, divide both sides by 2, and now I have cosine of x is square root 3 over 2. Quadrant time. Cosine is positive in quadrants 1 and 4. And the reference angle, the angle that makes cosine pi over square root 3 over 2 is pi over 6. So I'm going to come and add to my answers the pi over 6 angle in quadrant 1 and the pi over 6 angle in quadrant 4, 11 pi over 6. So those are all of the solutions, all of the x-intercepts between 0 and 2 pi. Okay? All right, number 6. What values or values of x from 0 to 2 pi satisfy this equation? So I have cosine of 2x is equal to sine of x. Well, again, I'm going to use my double angle identity, this time for cosine. So that's going to be cosine squared x minus sine squared x. Okay? And at this point, I've got sines and cosines, so I think I'm going to use my Pythagorean identity on cosine. Since I have a plain sine x and this sine squared x, I'm going to use my Pythagorean identity, and the identity that says cosine squared plus sine squared is 1. I can change cosine squared to 1 minus sine squared, right? So cosine squared x is 1 minus sine squared x. I still have this minus sine x squared x. I'm going to pull this regular sine x to the left, get everything on to get 0 on one side so that I can factor eventually. And now I have 2 sine squared x minus sine x plus 1 is 0. And it's time to factor. But there's nothing in common like there was in common in the last 2 problems. Instead, I have 3 terms: a square, a plane, and no sine x with that one, right? So this factors like a quadratic with 2 sets of parentheses. What 2 things multiply together to get 2 sine squared x? 2 sine x and sine x. They foil together, the first step in foiling, the f part of FOIL, that will get back that 2 sine squared x. Fortunately, there's just a 1 in the back, so only 2 things will do that, 1 and 1. Okay? Since it's a plus here, since it's a plus there, I'm going to need the same signs, and oh, I see what I did. I see what I did here. I messed up my signs up here in this step, didn't I? This should have been a -2, correct? Do you agree? That should have been a -2. I messed up my signs. So this will be wrong. I knew I was in trouble because I couldn't factor that. So I knew I had made a mistake. So this should be a negative 2 sine squared x because of these two. All right. So before I do anything else, I like to have my squared term to be positive. That's probably why I did that little mistake. I'm going to multiply both sides by negative 1 to force that to be a positive 2 sine squared. Okay? And now we will factor with 2 sets of parentheses. And we're going to have 2 sine x times sine x, a 1 and a 1. Since this is a minus, I know I need different signs. I need this to be a plus in between, so I want that 2 to be multiplied by a positive 1. This will be in the negative. Do your quick check to make sure that it works out. 2 sine x minus sine x is indeed positive sine x, so that does check out. So we have 2 sine x minus 1 is 0, or sine x plus 1 is 0. If we subtract 1 over, divide by 2, we will have sine x as a positive 1/2 again. That's quadrants 1 and 2. The reference angle is pi over 6. So we get x is equal to the pi over 6 angle in quadrant 1 and the pi over 6 angle in quadrant 2. For this other piece, I have sine of x is negative 1. For that, I like to look at the graph. I will draw the graph of sine x from 0 to 2 pi. Where is sine x negative 1? Well, sine is negative 1 right here. What angle is that? Well, this is 0, this is 2 pi, this is pi, so this is halfway between pi and 2 pi. That is the 3 pi over 2. So I'm going to add 3 pi over 2 to my answers. A bit longer of a solving one. Okay, one more example here. Find the zeros of this equation. So zeros mean we're putting 0 in for y. So we're going to have cosine of 2x plus 2 cosine squared x minus 2 is equal to 0. I'm going to change cosine of 2x to cosine squared x minus sine squared x. I have this plus 2 cosine squared x minus 2 is 0. I have 2 cosine squares, and then I have the sine squared x. I'm going to change sine squared to 1 minus cosine squared, again using that trig identity, but I'm going to have to be careful because there's a minus here. So I'm going to use parentheses to keep everything straight. Hopefully I can keep my signs straight this time. Okay? So we're going to have cosine squared x minus 1 plus cosine squared x plus 2 cosine squared x minus 2 is 0. Okay? So how many cosine squareds do we have? We have 4 of them. Minus 3 is 0. Since there's only one trig function here, I'm just going to solve it for cosine x. So I'm going to add 3 to the other side, divide both sides by 4, and now I'm going to square root both sides. When you square root both sides, don't forget your plus or minus. We're going to have cosine x is positive or negative square root 3 over square root 4. Square root of 4 is 2. This puts us in all 4 quadrants. And the reference angle that makes cosine square root 3 over 2 is pi over 6. So we get that x is the pi over 6 angle in quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And that is some of the things we can do with the double angle formulas.